Review Chapter 10. This is the first half of the Chapter 10 review, 10.1 through 10.4. So let's get started on our problems here. 10.1 was areas of parallelograms and triangles. So our first problem here has a composite figure, and we're going to break it down into figures that we know. So I see a rectangle, and the rectangle here has a base that's 15 inches and a height that's 5 inches. And so I can find the area of my rectangle. We know is base times height. So that equals 15 times 5. The area of my rectangle is 75 inches squared. Now let's take a look at our triangle here. The base of our triangle is right there, and so to find that base, we need to take the entire length, which is 15 inches, and subtract off these pieces on the side. So we'll subtract 3, and 3 more, so that's going to be 9 inches, and the height of our triangle is right here. And so we're going to do exactly the same thing for that. We know the total height of the figure is 11, and we're going to subtract off the height of our rectangle, which is 5, and we get our height is 6 inches. So we can find the area of our triangle. We know that's 1/2 base times height, so 1/2 times 9 times 6, and that is going to be 27 inches squared. And then we find our total area. This is a glue stick problem, so the total area is the area of the rectangle plus the area of the triangle, so that simply equals 75 plus 27. Our total area equals 102 inches squared. So those are easy enough. Let's look at our next figure, and we're going to break this into a rectangle. And I see that our rectangle here, the base of the rectangle is right there, so it has to be 11. Base equals 11 feet, and we need to know the height. This is the height of both our triangle and our rectangle. So how are we going to find the height of that? Well, what we have a triangle, a right triangle, and we know that this side measures 2, the hypotenuse is 6, and we are looking for that right there. We could call that H. Might as well call it H. So we know we need to use Chapter 8. Well, this is a right triangle, and we know 2 sides, so we're going to use the Pythagorean theorem. So this is A, B, and the hypotenuse is always C. So let's find A squared plus B squared equals C squared. H squared plus 2 squared equals 6 squared. This is 4. 36, subtract 4 from both sides. H squared equals 32. Now we need to square root to get H by itself. So H equals the square root of 32. So let's simplify our radical. We need to factor out any perfect squares. First perfect square is 4. Hey, that goes into 32. And it goes in 8 times. Now we can factor 8 again, square root of 4, square root of 2. So our height equals square root of 4 times square root of 4 times square root of 2. That's 2 times 2 times square root 2. Our height is 4 square root 2. So we now know 4 square root 2 feet is our height. So back to our rectangle. Our base is 11 feet. Our height is 4 square root 2 feet. we just do the area of a rectangle is base times height. This equals 11 times 4 square root 2. So the area of our rectangle is 44 square root 2 feet squared. And then we can move on to our triangle. We know that the base of our triangle is 2 feet. We know the height of our triangle is 4 square root 2 feet. And we can do area of a triangle is 1/2 base times height. So that's going to equal 1/2 times 2 times 4 square root 2. And that is going to equal 4 square root 2 feet squared. And then we want to find our area total of this figure is the area of our rectangle plus the area of our triangle, and that equals 44 square root 2 plus 4 square root 2. So our total area, these add up just like if the square root 2 was an x. So if you had 44x plus 4x, you would end up with 48x. It's the same way with a square root. So 48 square root 2 feet squared. And if we were asked to put this in decimal form, we throw it into our calculator. 48 times square root 2 is 67.9 feet squared. So that's in simplest radical form and to the nearest tenth. Okay, on to 10.2. 10.1 was really easy. 10.2, areas of trapezoids, rhombuses, and kites. And we should note the area of a trapezoid is 1/2 times the height times the sum of the bases. And area of rhombuses and kites is 1/2 times diameter 1 times diameter 2. All right, let's look at our first problem here. I see a trapezoid. We know these are the bases because they are parallel. So base 1 is up here the entire length, so we're going to do 20 plus 6 and get 26 inches. And base 2 is 14 inches. Now we need a height. How are we going to get this height right here? Well, you see it, I see it. We have a special right triangle, and it measures 60 and 30. And so we know that's chapter 8. We know the 30, 60, 90, short leg is x. The hypotenuse is 2x, and the long leg is x square root 3. Do we know any of these pieces? Yes. That side is 6, so that means our height is 6 root 2. So this is 6 square root 2. So we can now say our height is 6 square root 2 inches. We have everything we need. So the area of a trapezoid, we write our formula here. Height times the sum of the bases, the quantity of the sum of the bases. We substitute in. Our height is 6 square root 2. Base 1 is 26 plus 14. So that is 1/2 times 6 square root 2. You do the sum of the bases first. Parentheses are always first, so that's 30. And then we just multiply our regular numbers, this and this and this. And so our area of our trapezoid is 3 times 3. That's 90. Oh, hold on there. That's 40. There we go. Oh, that's so much better. How'd you let me do that? All right. So 3 times 4. That's 120 square root 2 inches squared. And that's in simplest radical form. Throw that into our calculator. Is that 207.9? 207.9 inches squared if we wanted to round it to the nearest tenth. So there we go. All right, next. Ooh, I see a rhombus. So we know that we need diagonal 1 and diagonal 2 on our rhombus here. So we know that diagonal 1 is 10 inches. We need to find diagonal 2. How are we going to find diagonal 2? Well, I see if we draw in our other diagonal here, that's diagonal 2, we know that the diagonals are perpendicular. In a rhombus, diagonals are perpendicular. Right? Our diagonals are perpendicular and our diagonals bisect each other. So that and that. So we can draw a right triangle. This guy right here. Doesn't quite look right, but it is because we say it is. And we know that this top is 8 inches long. And how long is this piece right here? Well, this is 5 and 5 because our diagonals bisect. So that one's 5. And we are looking for x. Right there. Right triangle, we know 2 sides. So that's a squared plus b squared equals c squared. And we have leg, hypotenuse. So x squared plus 5 squared equals 8 squared. That's 25, 64. Subtract 25 from both sides. And x squared equals 39. Get rid of the squared, we square root. So x equals the square root of 39. Can we simplify our radical? 4, no. 9, no. 16, no. 25, no. Square root of 39 is square root of 39. So we know this right here is the square root of 39. This right here is the square root of 39. Diameter 2 is the square root of 39 plus the square root of 39. That equals 2 square root 39. Think of these like x's. That's inches. If you had x plus x, it would be 2x. So that lets us just do our formula. So the area of our rhombus is 1/2 d1 d2. We simply put in d1 is 10, d2 is 2 square root 39. We just multiply our regular numbers. So the area of our rhombus is 10 square root 39. This is inches squared. And if we wanted to turn that into a decimal, that's 62.5 inches squared. So there's the area of our rhombus. Use those right triangles to your advantage. Okay, moving on. Areas of regular polygons. Now we know that the area of any polygon is 1/2 AP, or 1/2 A, and then P is just the number of sides times the side length. That's our perimeter right there. NS is perimeter. So how do we start any one of these problems? N equals S equals A equals. And then find our center. There's our isosceles triangle. We drop the altitude, which is our apothem, and then we have a triangle we can work with. So this is the little triangle in the middle there. This is always our apothem, this is always our radius, and this is 1/2 of our side length. Okay, we are ready to go. What do we know here? We know the number of sides is 6. We know a side length is 20 centimeters. And now we need to find parts of our triangle here. We need the central angle, 360 divided by 6 sides is 60 degrees divided by 2, because we're cutting those in half there, is 30 degrees. And we are in no way surprised by that because this is a hexagon. And so now we have a special right triangle, x, 2x, x root 3. And what else do we know on our triangle here? We know that the side length is 20, so half of a side length is 10. So our altitude, or our apothem here, is 10 square root 3. So we now have 10 square root 3 centimeters. And then we simply write our formula. Area of our hexagon equals 1/2 NSA. So that's 1/2. Number of sides is 6. Side length is 20. Be careful, it's the side length, not the half of the side length from our triangle. And our apothem is 10 square root 3 tall. And we just multiply our regular numbers. So the area of our hexagon is, times 10 is 100, 600 square root 3. That's centimeters squared. If we wanted that in decimal form, we just throw it into our calculator and get 1039.2 centimeters squared. Easy, easy. All right, this next one, we have triangle. Same story. N equals, S equals, A equals. And here is our isosceles triangle and the right triangle that we're getting out of it. And that is the one that we want. So we draw it here. And we know this is apothem, half of a side, and radius. And what do we know about this one? We know it's a triangle, 3 sides. We don't have a side length. We don't have an apothem either. Uh-oh, what are we going to do? What do we have on this one? We have our radius. So we know that this side is 5. All right, we got to fill in our triangle here. 360 divided by 3 sides is 120. Cut this in half here, divide by 2. So 60 degrees, 30 degrees. It's a special right triangle, but it's different from our hexagon, so be careful. It's a 30, 60, 90, but this time the short leg is here on our apothem. Hypotenuse is 2x, and half of our side length is x square root 3. So what do we know this time? We know that 2x equals 5. Find the color here. 2x equals 5, so x equals 2.5. So that means that our apothem is 2.5 and this side is 2.5 square root 3. Now what do we know about this? We know this is half a side. So we need to multiply that, our side length, so we can fill in our apothem is 2.5 feet, and our side length is 2 times 2.5 square root 3 equals 5 square root 3 feet, right? And then it's just do the work. Area of our triangle equals 1/2 NSA. 1/2, number of sides is 3, side length is 5 square root 3, and the apothem is 2.5. So we just multiply by all our regular numbers and we get 18. The area of our triangle is 18.75 square root 3, and this is feet squared. Or we throw that into our calculator and get 32.5 feet squared rounded to the nearest tenth. All right, that went fancy. That was easy. If you're careful on these, follow the steps. N equals S equals A equals. Draw your triangle. Don't forget that the base of the triangle there is half of your side length, or your side length is twice the base of the triangle. Find your angles, find your central angle, cut it in half, fill in your other angle. And so far, all we're using is special right triangles. So that'll be triangles, hexagons, and squares. And then you just put it into the formula, and it's easy as can be. All right, and 10.4, our last section here. We know, we should write up here, we know that scale is A to B. Perimeter ratio is also A to B. They're both lengths. And area ratio is A squared to B squared because, area. All right, let's look at our first problem. The figures are similar. Good to know. We want to know what is the ratio of the perimeters and the ratio of the areas. If the larger rectangle has an area of 36 centimeters squared. So the first thing I'm going to do, I'm going to label small, large, and what do I know? I know the area of this one is 36 centimeters squared. That's area large. And we are looking for area small. So the first thing I need to do is find my scale. And scale of, let's do small to large, is 2 to 3, right? I use my lengths. So now I have a scale, and we want the ratio of the perimeters. Well, if this is A and this is B, we know that the perimeters is just A to B. Your perimeter ratio is just 2 to 3 as well. So that was easy enough. And we want the ratio of the areas. So our area ratio is 2 squared over 3 squared. So that is a 4 to 9 ratio. So now we have perimeter ratio and area ratio, and now we want the area of the small triangle. So I am going to use my area ratio, 4 to 9, and write a proportion here. And area small and area large is 36. So then it's just cross multiply. So we can just call this X up here. Area small is just X. This is X, right? That's area small. So 9X is 144. Divide by 9. X equals 16. Area small equals 16. And what's our unit? Centimeters squared. So easy enough. You find your scale. Your perimeter ratio is the same as the scale. The area ratio is scale squared. And then I'm going to use one of those to write a proportion to find my unknown. We were looking for area, so I used my area ratio. And I just take my area ratio and use it to write that proportion. All right, last problem here. The areas of two similar octagons. So what are we given? We're given areas of our octagons is that and that. Find the scale factor. Right? Well, we know scale is a to b, and we know area is a squared to b squared. So we know our area ratio, and I'm going to put small on top, is 72 to 126. And I need to square root these, but I am going to reduce them if at all possible. Getting them smaller is better. So I can divide them both by 2. That gets me 36 over 63. Well, 36 is nice. 36 is a perfect square. So we're going to square root them now. And that equals 6. And we need to do the square root, simplify our radical here. 63. What goes into 63? 9 does. 9 and 7. So we end up with 3 square root 7. So that is 6 to 3 square root 7. So that makes scale 6 to 3 square roots. That's not a 7. And we could fix our denominator if we want to. It doesn't really matter so much on ratios because we are comparing two lengths. We could turn it into decimals if we really wanted to. So if you're given an area ratio, you have to square root because area is a squared and b squared. So to get scale, I have to square root. And that's it. On these, if you are careful and label everything and show your steps, you will do fabulously on the quiz.